Today I wanted to run through some of the tools that we have within SOLIDWORKS for working with mesh bodies or imported STL files. So here this is an STL file that I grabbed off Thingiverse, and this is a part that I want to be able to do some modifications on. This is actually an enclosure for an electronics assembly, and I would like to go through and sort of make my own modifications on this. This is an open source print file that you could go and grab on Thingiverse. But before I print it, I think I can optimize the flow of this a little bit better than might be currently existing in this particular box. So I want to go through and basically create a parametric model based on this STL file. Fortunately, SOLIDWORKS gives me some tools that make that a lot easier now. The primary tool that we're going to be using here is the slicing tool, but unfortunately, in order to use that slicing tool, the first thing we need to do is convert this STL file, which you can see is listed as a graphics body, into a mesh body. So if you go up to your tabs up here within SOLIDWORKS, you'll see that one of the new tabs that we have available is this mesh modeling tab. So that's the first thing you'll want to do, is enable that particular tab. And then once we have that, we can actually take this graphics body and convert that to a mesh body. So if I go ahead and activate that tool, we'll choose our graphics body as the body that we'd like to convert. We'll go ahead and leave on the group facets into faces option. Go ahead and click OK. And that's going to give us this imported body that you see over in the tree here, but it now actually treats that as a solid body. If we look at this, you can see that, yeah, it is actually a solid body here within SOLIDWORKS right now. If we do a section view on that, it's pretty easy to see. But again, I don't really have any geometry over here that I can go back and modify parametrically. So that's our goal here, is to go and get some features that I can actually modify and you know, tweak this model to what I'm actually looking for. So let's go ahead and explore the slicing tool. What this does, it effectively allows you to get a cross-section through various planes on your model. The way I'm going to do this is a little bit different. Typically with the slicing tool, what we'll do is go ahead and grab one face, and then you can go ahead and generate a number of different planes that you want to create here, and it'll effectively go and grab a cross-section at all of those different planes. What I'd like to do in this case, though, rather than create 6 different planes or X number of planes, I actually just want to create one. Because what I want to do here is just go in and grab the particular facets that I'm interested in that are going to serve as the basis for my future sketches. So here we can see there are a number of different surfaces within this box that I'm probably concerned with if I'm going to go ahead and create a parametric model for this. So once we have that face selected, we can go ahead and click OK, and it's going to essentially extract a cross-section of whatever face you had selected. That's pretty easy to see. If we go back and hide that imported body here, I can now see that, yeah, I've got a sketch down here. I can see it's not perfect. It has you know, little segments here, little line segments, rather than a true curved fillet. But that's the sort of thing that we can correct on our own sketch. Once we have a section like that, a cross-section, we could then go ahead and create a sketch on that same plane and go ahead and give it the proper size. But the nice thing is we have this sketch now that we can use as a reference. So I could essentially just go in here and kind of reference this as the size. Here I can see the vertical on that. It looks to be 124 millimeters. So I can go ahead and use that as my dimension. And then same thing here on the width of this. If I just sort of use that as a guide, again, it looks like it's about 124 millimeters wide. So that's going to serve as pretty much a perfect sketch to start off my first extrusion on this reverse engineering process. So that sketch is looking good. Let's go ahead and exit that one. We'll show our imported body again. And kind of moving on from here, you'll see that I have a few other features that I'm concerned with. So these bosses inside here, these are effectively standoffs for another part that's going to go on the inside here. That's probably another cross section that I'd want to make sure that I have within my sketches, and then again use that as a reference when creating this reverse engineered part. So once again, we'll go and grab our slicing tool. We just want to create the one plane. For our slicing planes, we can go ahead and choose that face up here. One of the things you'll notice here is that when we have chosen that face, it does limit our bounding box to that one face that we've selected. So one thing you might want to consider doing if you'd like to extract more than just that single face in this area is expanding your bounding box by grabbing these little arrows and just kind of pulling those out to wherever you need those to go. For this one, I might like to just make sure I have the entire part, once again, encompassed as part of this, this extraction for this cross section. So we'll just adjust our bounding box here to ensure that we're hitting all of the areas that I'm looking for. That looks pretty good right there. That should get everything that I need. We'll go ahead and click OK. And then once again, that's going to give me a sketch at that section there to allow me to utilize that as a guide when creating the rest of my sketches to reverse engineer this part. Okay, so let's run through that process maybe one more time. We'll try to focus on these bosses that we have down here. These are going to be standoffs for another little PCB within this enclosure. However, this time, if we go to our slicing tool, you'll see that we're presented with a bit of a challenge this time. I'd like to go and maybe add in a cross section at the top of these standoffs so I know the location of these and I can reference those when creating my reference sketch. However, you'll see here that if I try to grab those, whether it's the edge or the inside diameter here, it's not a plane. It's not being treated as a planar surface by the slicing tool. So what we might want to do in a case like this is go back and utilize another one of the mesh modeling tools that we have here, which is the plane tool. So this allows us to go in and add a reference plane using a reference from this mesh body. So here we'll go ahead and choose to do that. In this case, we're just going to use that edge right there, that circular edge, as our reference for this plane. And you can see that's going to create a plane coincident to that edge that we've selected there. You can see the plane looks rather small, but no big deal. Of course, as we all know, planes are infinite in two directions, right? So we can always go ahead and kind of resize that plane as need be. So now that I have that plane there, if we go back to our slicing tool, we should now be able to choose that plane as our reference plane. Again, just choose to create that one plane. And then once we've done that, we should have the locations of those holes there, which we can see right there. So it gives us a nice, in this case, you can see it's given us two concentric circles, showing us the location of where those standoffs need to go. You can see here you are getting some, I guess, some extraneous information in these planes. So it does have, all the different hole cutouts and everything over here. But of course, we're just using these as a guide, as a reference. So that then allows us to go in and place that hole and that boss exactly where it needs to be. So that's the process of breaking this up using the slicing command. You can see that that's very useful when it comes to reverse engineering a part like this. Now I have some good reference sketches here that I can then use to create fully dimensioned sketches that I can then use to create features, nice parametric features, and create the modifications necessary on this particular part.